Hello all, how are you?
Hello, sir.
Fine, sir.
Fine, thank you, sir. How are you?
I'm also fine. Okay. So in the last class, we have discussed the Kirchhoff's laws. So there are two Kirchhoff's laws. One is Kirchhoff's current law and another is Kirchhoff's voltage law. And we were discussing the Kirchhoff's voltage law. And I have told you if there is a rise in potential, then you will take the potential difference as positive. If there is a fall in potential, then you will take the potential difference as negative. Okay. So here in this loop, we have applied the Kirchhoff's voltage law, and we got this result. And I have also told you that if you are applying this Kirchhoff's voltage law, suppose if you are applying anti-clockwise, this is anti-clockwise, na? So the result will be this, and if you are applying clockwise, then also the result will be this. So direction of applying will not change the result. Okay, and this law is based on the conservation of energy. And first I will solve a question. So this is a question. Drive an expression for the internal resistance of a cell in terms of EMF and the terminal potential of the cell. Okay. So we already know what is cell, how is the cell is represented. So cell is represented like this, and suppose this is the internal resistance of the cell, and an external resistance R is connected. And if the current is flowing like this is positive, this is negative. So this is the discharging condition of the cell. This is the discharging condition of the cell if the current is flowing from positive to negative. Now this is a closed loop. This is a closed loop. Okay. So what is the potential if suppose, just wait, if this E, capital E is the EMF and small r is the internal resistance of the cell. Capital E is the EMF and small r is the internal resistance of the cell, and this capital R is the external resistance. So the potential drop across this external resistance will be IR. If current I is flowing, then potential drop V is equal to IR. Okay. And here, what is the potential drop? Here the potential drop will be I into small r. I into small r. Okay. Now take points. Suppose this is point A, B, C, and D. Now we will apply the KVL here, Kirchhoff's voltage law. So you can choose any direction. You can choose direction same as that of current. You can choose the direction opposite to the current. Okay. So Matthew, which direction do you want to choose? From in the direction of current you want to go, or in the opposite direction of current you want to go? You will get the same result.
So you can go in the direction of current.
Okay, fine. If you will go in the direction of current, means if you are moving like this in a mesh, you are moving like this. Means from A, the current is from like this, so you will move like this. Okay. D A, you will choose a path D A B C D. You will choose a path D A B C D. Okay, D A B C, T. This is a path you have chosen, and in according to this path, you will apply KVL. Okay, Nafisa, is it okay?
Yes, sir. Yes, sir.
Now you have to focus here. Now we are moving from D to A, and when we are moving from D to A, there is no resistance and there is no internal resistance. There is no cell. So here there is no potential drop. Okay. So when we are moving from A to V, here is a potential drop IR. Here is a potential drop IR, and we will take this as negative IR. Why? Because we are moving in the direction of current, and I have told you whenever we are moving in the direction of current, the potential drop will be taken as negative. Okay.
Yes, sir.
Now from B to C, okay, no problem from B to C, no resistance and no potential drop. Now from C to D, when you will move, you will get this is the direction of current. You will get this potential drop, and this potential drop will also be negative, minus IR. Okay. And now when you will move from negative to positive terminal, means you are moving from lower potential to higher potential. So you will take this E as positive, E as plus E you will take, and this is equal to 0 according to KVL. Now you can write this as E minus IR is equal to IR. And what is this IR? IR is the voltage drop across the resistance, and this is the equation we will get, E minus IR. So this is the derivation of oh, sorry guys, there was a power cut. Hello Nawal, how are you?
Hello, sir.
Okay. So Nawal, I am discussing this question. Just you can read this question, and I have we have this type of circuit, means we have this one cell, and this is the internal resistance, and here is the external resistance, and I have just simply applied the KVL. Okay, and I got this result. V is equal to E minus IR. So this is the terminal potential difference in terms of EMF and the internal resistance. So this is the way, with the help of KVL, you can prove this. So the question was, write the expression for the internal resistance of a cell in terms of EMF and terminal potential difference of the cell. And what is V? V is the terminal potential of the cell. I have discussed this many times. Terminal potential difference. Now, Nafisa, uh, what we will do now, earlier we have applied, we have chosen the path, all of you, earlier we have chosen the path D A B C D. D A B C D. Now I will choose a path opposite uh, in a direction opposite to that of current. Okay. So what is the direction opposite to that of current? So our current is in this direction. So I am now choosing a path D C B A, and we will see will the result change or not. D C B A. D C B A D. Current is in this direction, and we have chosen the direction of loop in this direction. DC. We will choose this path, and we will apply KVL. Apply KVL. Now, when we will move from D to C, here is a cell of EMF E, and now you can see you are moving from higher terminal to higher potential to lower potential. So this E you will take as negative, minus E. Okay, and this now you are moving in the opposite direction of current. The direction of current is this, and you are moving in the opposite direction of current means you are moving in the direction of uh, increasing potential. So this IR will be positive this time. Okay. Now from C to B there is no resistance and or cell. Now from B to A, when you will move from B to A, the direction of current is this. Okay, the direction of current will be this. Okay, and you are moving from B to A. Now from B to A, the potential drop is IR, so you will take this as positive, and this is equal to 0. We have discussed in the last class. So now this is minus E plus I small r is equal to minus IR. Now take minus common, so you will get IR is equal to E minus IR, and this IR is equal to V is equal to E minus IR. So again we have got the same answer. Again we have, and just V is the terminal potential difference. So this is the expression for terminal potential difference. Okay guys, just please note it down, take the screenshot, and then we will solve a question on the KVL, Kirchhoff voltage law.
Yes, sir. Took.
Yes, sir.
Taken.
Taken na? Nawal?
Yes, sir.
Okay. Taken the screenshot na?
Yes, sir. Yes, sir.
Okay, just take this, because I want to tell you that if you will change the path of the loop, means in which path you are moving, if you will change, the result will always remain same. That thing I want to tell you. So just take the screenshot of it also.
Yes, sir. Finish.
Okay. So now just there is a thing that I want to discuss. The question that I will discuss now is a bit lengthy question, but this type of lengthy question you will not get in your examination. You will get either one part or two part of this question at least. Okay. So I have taken this question because all the concepts will be clear. Okay. In one question. All the things I have included in one question. Okay. And don't think this question will appear in your examination. Whole of the question will appear in your exam. Okay. There can be one part or two part can be asked in your examination. Okay. So this is the circuit we have. This is the circuit we have, and we have to calculate the current through each resistor, voltage across each resistor, power dissipated across 5 ohm resistance. Okay, and potential difference between A and F and potential difference between B and E, and this is one of the most important question of KVL. Okay, so what I will do, first I will analyze this circuit. First we will analyze this circuit. We will see whether there will be a parallel. Can we solve this circuit with the help of series and parallel connections? Series or parallel combination. So in this circuit, if you can see it, then you will observe that there are no series and parallel connection. But here is only one series connection, but that is not enough for solving the circuit. Okay, so as we have to find the value of current in each of the resistance, so if no series and no parallel combination in the circuit and we are confused which combination is this, and if there are no possible series and parallel connection, so there is only thing that can solve the question. There is a thing that can solve the question, that is KVL, Kirchhoff's voltage law. Means you will apply the Kirchhoff's voltage law and you will get your answer. The complex circuits you can solve with the help of Kirchhoff's voltage law. Okay, but the condition is that you should know how to apply that. Okay, you should know how to apply that. So this is the circuit, and we have to apply the Kirchhoff's voltage law in this circuit, and we will see how the current will be calculated with the help of that. Okay, so now, so there are the steps that you have to follow. First, name the points A, this is points B, this is C, this is D, and please have patience. D, this is F, this is E. We have named the point. Okay. Now we will consider the current in the circuit by ourselves. We will consider the current in the circuit by ourselves. So step first is division of current. Okay. Now we will do the division of current in the circuit. So I am just supposing, you can suppose anything. I am just supposing, suppose I1 current is going in this direction. I1 current is going in this direction. You have to suppose the current by yourself. You can suppose the current from here also, from here also, from here also. I am just supposing the current from here. Suppose the I1 current is going in this direction and we do not know the value of I1. Okay. So as from here to here to here to here, the wire is same, so the current will remain same. So here also the current will be I1. Now you came, you come to the point D. When you will be at point D, so you can see at this point there are branches here. There are branches, so means this current I1 will divide. Okay, suppose from this point D, I2 current is going in this direction. So what will be the current in this direction now? What will be the remaining current in this direction now, Nawal? Along the direction DE, what is the remaining current? If I1, I1 was the current earlier here, and I2 was the current going in this direction. Now, what is the remaining current in this direction? Can you tell me? Anyone?
I3.
No, not I2. You have current I1 here.
I1, right?
No, not I1. See here, this is the junction point, na? Here, I1 current is going towards the junction, and this is the junction. So this I1 current will be divided in this direction and in this direction. This I1 current will be divided in this direction and in this direction. I am supposing I2 current from this I1 current is going in this direction. So the remaining current in this direction will be
I1 minus 2.
Hmm, 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 hmm. Yes. And if you are confused, then you can apply the Kirchhoff's current law also. All of you can see I1 current is coming like this, and we want to find the current in this direction. And here we have current I2. I2. So I have told you, you have to take the summation of the current. So current entering you will take as positive current. So this is current entering towards the junction. This is the junction point D. Current entering I1 you will take plus I1, and current leaving the junction you will take minus I2, and this current I we have to find. This is also the leaving current. This is equal to 0. When you will solve this equation, you will get I1 minus I2. I1 minus I2. So means in this direction, the current will be I1 minus I2. So if you are confused, then you can use KCL, Kirchhoff's current law. You can apply at the junction point. Okay, this is the junction point. So as from DE, the wire is same, the current is same, means here also the current is same. Here also the current is I1 minus I2. I1 minus I2. So means from here to here the wire is same, the current will remain same. Okay, so means here also the current is I1 minus I2. Okay, now this is the junction point here. This is the junction point here, and I2 current is coming from here. I2 current is coming from here, and I1 minus I2 current is coming from here. And so can you tell me what is the current in this branch BC? Can anyone tell me? Both the currents are meeting at this point C.
I1.
It will leave.
Nawal, do you have any idea? Okay, no problem. Matthew, you are right. Why the current is I1? Because
I2 get cancelled from
yeah, because I2 get
I1.
cancelled. If you will apply the KCL, if you apply the KCL here, okay, then you will get, means you will add this current, and this current. When you will add both the current, I2 and I2 will get cancelled out. You will get current I1 only here. Here also the current will be I1. So this is the division of current. Okay, in this way you have to divide the current in the circuit. Now we have two variables. Step second. Please, at least I want that you should focus on the screen. If you are not getting anything, then you can ask me. Okay, this is not very tough. This is not the rocket science. Okay, this is simple things. This is looking complicated, but this is not complicated. Step second, we have two variables. We have two variables. Two variables, that is I1 and I2. we have considered one variable I1 and another variable I2. Okay, we have only two variables here, so we do not know the value of I1 and I2. So what we will do, we for finding the value of two variables, that is I1 and I2, at least two equations should be there. At least two equations should be there, and with the help of KVL we can form the equations. With the help of KVL we can form the equation. So we have to choose. So you can write, we will apply KVL in two loops. Loops means this closed loop. One loop is this, another loop is this, and another loop is this. Okay. Step second. Now it is decided that we will take two loops, and which loop you will take. So in the first loop, suppose in a first loop I want to move like this, in this direction, and in the second loop suppose I want to move in this direction. This is the direction that I am choosing. I have already told you, you can choose any direction, you will get the same answer. So I have supposed the loop first ADCBA. So we have choose first ADCBA. This is the loop I have chosen, and another loop I have chosen. This is the first loop, this is the second loop, and this is a path in the loop that I have chosen. Okay. So now we will apply KVL. Apply KVL in loops. So what is the path we have chosen for the first loop? The path I have chosen as ADCBA. ADCBA. So path ADCBA. Okay. So now we will apply the KVL here. So I am taking this diagram. Okay. Now just see this loop ADCBA only. So when you are moving from A to D, when you are moving from A to D, so and tell me one thing, what is the potential drop across this 10 ohm resistance? This will become 10 I1. Is it or not? Because V is equal to I into R. Okay. Is it or not?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So when you are moving from A to D, means you are moving in the direction of the current. So you will take this 10 I1 as negative. So you will take this as minus 10 I1. Now you will move from D to C. From D to C, what is the current? I2, and what is the resistance? 5. So what you will write? Minus 5 I2, because you are moving in the direction of current. Minus 5 I2. Now from C to B, there is nothing. Now you are moving from B to A. From B to A, for this 1 ohm resistance, you will write minus I1 only, because when you will multiply I1 with 1, it will become only I1. So this is I1 only. And from here, lower to higher. So you are moving in this direction, and means you are moving from lower potential to higher potential. Lower potential to higher potential means you are moving in the direction of increasing potential. So you will take this as plus 2, and this all equal to 0. So finally you will get this equation. minus, this is minus 10 1, this is minus I1, this is minus 10 I1, this is minus I1, you will get minus 11 I1 and minus 5 I2 plus 2 is equal to 0. When you will take minus common, you will get 11 I1 plus 5 I2 minus 2 is equal to 0. This is our equation number 1 we got when we applied the KVL in this loop. Now we will get the equation number 2 when we will apply KVL in this loop. So now we are applying KVL. Suppose this is loop 1, this is loop 2. Loop, and you will have to choose the path also. So what is the path you will choose? So just you can choose the path in the opposite direction of the current. So this is the path I have chosen, DCFE, DCFED. Okay, this is the path, means you are moving clockwise. So you will choose this path, DCFED. This is the clockwise path, and this is the anti-clockwise you have chosen. Anti-clockwise. So now we will apply the equation DC. When you will move from D to C, when you will move from D to C, you are moving in the direction of current. So you will take this as minus 5 I2. Minus 5 I2 you will take. Now from here to here, you are moving in the opposite direction of current. Now you will take plus 5 and I1 minus I2, because current is I1 minus I2. Here you will take plus 5 I1 minus I2. Now from F to E, you will take this plus 2 I1 minus I2. Now you are moving from higher potential to lower potential, so you will take this as minus 5 and this is totally equal to 0. So when you will solve this equation, so this is minus 5 I2. So here you will get this is 5 plus 2 7 I1 minus I2 minus 5 equal to 0. So this is minus 5 I2 plus 7 I1 minus 7 I2 minus 5 equal to 0. So this is minus 5 I2 minus 7 I2. This will become minus 12 I2. This is plus 7 I1 minus 5 equal to 0. Okay. So when you will take minus common, you will get 7 I1 minus 12 I2 plus 5. You are moving from higher to lower. Okay, so you will take this as minus 5. So this will become plus 5 now. Just wait. This is minus 5 I2. This is 7 I1, 7 I2, and this is minus 12 I2 plus 7 I1 minus 5. So this will become plus 5. Oh, one thing is there. Okay, is it fine? This is fine. Here you will take minus 5. Okay, when you will take common minus from here, this will become plus. Okay, just this is 7 I1 You will write here 7I1 and this is minus 12I2. You will write here, and this is minus 5 equal to 0. This is equation number 2 you will get. Okay, this is equation number 2 you will get. So now you have to solve both the equations. Solve equation 1 and 2. When you will solve it, what is the equation 1? Equation 1 is this. And equation second is this. This is the equations that you have to solve. So this type of equation you can solve easily. Okay, in 10th class also you have solved these types of equations. So I am just reminding you what you have to do. Okay, you can cancel any of the variable I1 or I2 from this equation. So what you will do, you will multiply this 7, the coefficient of I1, to this equation, and coefficient of I1 from this equation, that is 11, to this equation. And finally you will get, when you will multiply this 7, you will get 77 I1 plus 35 I2 minus 14 equal to 0. Okay, and when you will multiply this will become 77 I1, and this will become minus, when you will multiply this, 132 I2 and minus 55 equal to 0. Now you can solve both the equations. Here is minus, here is plus, here is plus. So this and this will cancel out, and 35 plus this will become 35 plus 132 will become 167 I2. Okay, and this will become plus 41, and this is equal to 0. So what is the value of I1? You will get, sorry, I2 you will get minus 41 divided by 167, and when you will divide this you will get minus 0.24 ampere. So I2 you have 0.24 ampere you will get, and we have got the negative sign of the current. So this negative sign shows that the direction, the actual direction of current, actual direction of I2 is opposite to that of we have assumed. Okay, you can write in the examination also like this. No need to change the direction of I2 here. Means we have choose the direction of I2 in this direction, but in actual the direction of I2 is in this direction. So this is the meaning of this negative sign. Okay, so we got I2 now. Now we will solve for I1. So put this I2, that is minus 0.24 ampere, in equation 1. You can put in any of the equation. When you will put this in equation 1, 11 I1 plus 5 into minus 0.24 minus 2 equal to 0. You will solve from here. You will get I1 is equal to 0.29 ampere. Okay, you have, what you have done, you have just put this value of I2 in this equation. Okay, 11 I1 5 I2 minus 2, 11 I1 5 I2 minus 2, you will get I1. So now you have I1, now you have I2. Okay, You have I2 also. I1 you have 0.29 ampere, and I2 you have minus 0.24 ampere. Now we can find I1 minus I2. When you will find I1 minus I2, you will get 0.53 ampere. 0.53 ampere you will get. So the current part we have completed. Okay. So the calculation is little bit complex for you. Okay. Just copy this. Then we will discuss the other part. All of you, please copy this. Means you have to make two equations by applying the KBL in two loops. In one loop, when you will apply KBL, you will get one equation. In second loop, when you will apply KBL, you will get second equation. When you will solve first equation and second equation, you will get the values of two variables. Here we have two variable as I1 and I2, and we have find it out. Okay, Matthew, Nafisa and Nawal.
Okay, sir.
Yes, sir.
Okay, just please note it down, and after that we will discuss the further parts.
Uh, Sir, can you scroll down?
All of you, should I scroll down?
Yes, sir.
Okay. And please make the diagram properly. Show the direction of current properly. Okay. This yellow color arrow means we are moving anti-clockwise in the loop. Okay. Now 85% question has been solved already. 80 to 85% question is solved when you are able to find the current. First step is the division of current. You will choose the current according to you. Okay. You can take any direction of the current initially, and but when you solve the equation, if you are getting a negative current, means you will take the direction of current opposite to the direction that you have supposed. Okay.
Yes, sir. Finish.
means we have solved 80% of the question, means 85% I will say of the question have been completed now. Other all the parts now we can solve very easily.
So can you scroll down?
Yeah. Or don't make this diagram again. This is just for your understanding. I can. Nawal, are you getting?
Yes, sir.
When you will do practice, then it will become very easy for you. The direction part means if you are moving the direction of the current, then you will take the potential drop as negative. When you are moving in the opposite direction of the current, then you will take the potential drop as positive. And I have told you these things with a reason. I okay. In the starting, I have told you why we are taking a negative sign, why we are taking the positive sign of the potential drop. And this chapter is just going to end. After this chapter, we will start the moving charges and magnetism. That chapter is very interesting.
So can you scroll down?
Nabal and Nafisa, should I scroll down?
Yes, sir. Scroll down.
Yeah. Okay. If you are finally getting the negative value of the current, it means that the actual direction of current will be opposite to the assumed direction of it. Okay. When completed, please tell me.
Yes, sir.
So I1 is 0.29, right?
Yeah, I1 is 0.29 ampere and I2 is minus 0.24 ampere. And I1 minus I2, when you will do I1 minus I2, you will get 0.53 ampere. Ampere is the unit of SI unit of current. And ampere is a name of the scientist also.
So
In
for I1
magnetism,
minus I2, you wrote I1 minus I1.
oh sorry, thanks,
No problem.
thanks Matthew. This is I1 minus I2, okay. And in the magnetism, we will study a law called as Ampere circuital law. There we will calculate the magnetic field with the help of that law. Okay, completed all of you?
Yes, sir.
Yes, sir.
Okay. Now start the first part of the question. We will solve the first part now. Now this question becomes very easy if we have all the things. Now they are saying in the first part, they are saying current through each resistance. Current through each resistance. So each resistance means current in 1 ohm, 10 ohm, 5 ohm, 2 ohm, and this 5 ohm. So just I am taking the current in 1 ohm. In 1 ohm. What is the current in 1 ohm resistance? Okay. So what is the current in 1 ohm resistance? I1. Simply, you can write the value of I1. That is I1. I1 is equal to 0.29 ampere. This is the first answer. If you want to calculate the current in 10 ohm resistance, this, what is the current? Current is I1. You can see here. What is value of I1? 0.29 ampere. What is the current in this 5 ohm resistance between D and C? In 5 ohm between D and C. What is the value of current? I1 minus I2 na?
0.24.
I1 minus I2 is the current here. I1 minus I2. Oh, sorry, not I1 minus I2.
No, sir, it's
I2.
I2, you're right.
It's I2 only. So just write the value of I2 only. I2, what is I2? I2 is minus 0.24 ampere. See how simple this question becomes. So if you want to find the current in this 5 ohm between C and F, in 5 ohm between C and F, what is the current? See here, I1 minus I2. I1 minus I2, I have already find I1 minus I2. You can see here. This is 0.53 ampere. 0.53 ampere. And last is in 2 ohm resistance. Can anyone tell me what is the value of current in 2 ohm resistance? Again, this is I1 minus I2. You can see here.
0.5.
The current will be I1 minus I2 and the value will be 0.53 ampere. Okay, the first part of the question is completed now. Now second part of the question, they are saying calculate the voltage across each resistor. Voltage across each resistor. Second part. You have to take this diagram. All the things you will do from the diagram only because it will be easy. Okay. Now across each resistance we have to calculate the potential difference or voltage. Now I am just calculating voltage across 1 ohm. What is the voltage across 1 ohm? V is equal to IR. What is current in 1 ohm? I1 into 1. I1 into R is the voltage now. So I1 into 1 you will write here. I1 into 1. What is I1? 0.29. And when you will multiply it with 1, this will become 0.29 volt. If you want to find voltage across this 10 ohm, you want to find, then what you will do? What is the voltage? This will be 10 into I1. This will be 10 I1. What is the value of I1? 0.29. You will get
2.9.
2.9 volts. Now across 5 ohm between D and C, across 5 ohm between D and C, what is the voltage? I2 into 5. I2 into 5, what is the value of I2? See here, I2 is 0.24 ampere, minus 0.24 ampere, minus 0.24 ampere into 5. When you will multiply this, you will get your answer. Okay. Now, if you want to find the potential, voltage across the point C and F, means across 5 ohm, means across 5 ohm between C and F. What is the voltage? I1 minus I2 into 5. Voltage is equal to current into resistance. So current is I1 minus I2 and you will multiply it with 5. I1 minus I2 into 5. I1 minus I2 into 5. What is I1 minus I2? 0.53 into 5 and you can calculate it by yourself. Now across 2 ohm, now Nawal will tell what is the potential difference or the voltage across this 2 ohm resistance. Nawal, actually Nawal, your voice is not clear. Okay, no problem. Nafisa, can you tell me what is the voltage across this
I1
2?
minus I2 multiplied by 2.
Yeah, very good, very good. I1 minus I2 multiplied by 2. B is equal to I into R. This is current, this is R, and I1 minus I2 I have already calculated 0.53 into 2, and you can do this calculation by yourself. So we have just completed the second part of the question. Now third part of the question, they are saying power dissipated across 5 ohm resistor, 5 ohm resistor between I am saying C and F. We have two 5 ohm resistance, that is why I am writing between C and F. So between CF and C and F means we have to calculate power dissipated in this resistance. Matthew, why the power is dissipated in the resistance? There is some reason.
Due to an internal resistance.
Yeah, means across the resistance, whenever the current flows, heat is generated. Due to that heat generation, the power is dissipated. Okay. We have a topic also, power dissipated, in the circuit. The last topic of this chapter. Okay, we have to just find the third part, and I will represent power with P, power dissipated with capital P, and the formula of power dissipated, we have three formulas of power dissipated. Can anyone tell me what is the formula of power dissipated across a resistance? Okay, no problem. Just see. I square R. Second formula is V square divided by R, and third formula is V into I. So you can apply any of the formula. I am just applying here P is equal to I square R because I am having I and I am having R also. So power dissipated across 5 ohm between C and F. C and F. This resistance C and F. So what is the power? I square. What is I here? I1 minus I2 square into resistance R. R is 5 ohm. So this will become 0.53 square into 5, and I think you can calculate this by yourself. So this is the third part. First complete these third part, then I will solve fourth and fifth part. Okay, please just complete this first. All of you just complete this. And please ask me to scroll down when completed. Completed, Matthew?
Just a second, sir.
Okay. All of you just please complete it fast.
Done, sir.
Nafisa and Nawal,
Yes, sir, done.
you guys are fast. And please, now no need of this diagram. Don't make this diagram again and again. Okay. So you can start from here. You can do this calculation by yourself. Okay. Uh, Guys, are you getting what I am teaching today?
Yes, sir.
Yes, sir.
I know this is little bit complicated for you, means the equation part is complicated for you. And believe me, when you will do the practice, this will become very, very easy for you. And please, when completed, Matthew, you can ask me to scroll down.
All right, sir.
We are on the third chapter and we have to complete the syllabus also on time. You have one topic, proof of Wheatstone bridge, and after that you have actually potentiometer is now not the part of your syllabus. You instead you have a meter bridge, and then the heating effect of current, and then your chapter is finished.
Done, sir.
Yeah, okay. Just please don't make this diagram. Because you have already drawn this, so no need to draw it again and again. The examiner can ask you either one part or two parts only. He or she cannot ask whole of the 6 part. If he will ask, then it will take at least, I think, 1 hour to solve for the student. Not the 1 hour, it will take at least 30 minutes. And how much amount of time you get in the examination to solve the question
3
paper?
hours.
3 hours only,
3
na?
hours.
And okay. And when you when you will go to the final exam, please remember one thing. Try to focus on your speed also. Try to focus on your accuracy also. Okay. Try to focus on your writing skills also. How to write how to write an answer. Okay.
Yes, sir, finish.
Finish.
Yeah, done.
Matthew, finish. Okay. Okay, fine. So fourth part. I am discussing the fourth part now. Fourth part. So in the fourth part, just see this circuit. They are saying that in the fourth part, they are saying potential difference between A and F. We have to find the potential difference between A and F. So see how we will find the potential difference between the point A and F. Between the point A and F. Between the point A and F. So you can choose the path from A to F as A, B, C, F, or you can choose the path A, D, E, F. A, D, E, F. You can choose any path. Okay, I am choosing the path A, B, C, F. Okay. A, B, C, F. Okay, when you will move from A to B, you have this cell, and for this cell, you are moving from higher to lower. So you will take this. Okay, first you will start from this point A. You will take the potential of this point A, VA. You will write VA. Okay, you will write VA. Now you will move to this. Here you will write -2, and you are moving in the opposite direction of current. So here you will write +I1, because when you will multiply it by 1, so it will become I1 only. Now from here to here, you are moving in the opposite direction of current. So here you will write +5I1 minus I2, and here this point F, you will take minus V suffix F equal to 0. From here you can find the potential difference between the point A and F. So all the things we have, I1 we have, what is the value of I1, Matthew? 0.29.
Yeah, sir. 0.29.
0.29, and this is 5 into 0.53. This is minus VF equal to 0. So you can now find VA minus VF. This calculation you can do by yourself. This is the simple calculation you can do. Now, in the fifth part or in the sixth part, they are asking what is the potential difference between the point B and E. Between the point B and E. So, between the point B and E. So, I am choosing a path B, C, F, E. This is the fourth part now.
Yeah, sir.
This is the fifth part. Huh? This is the fourth and this is the fifth part. We are on the fifth part now. So okay. Now we have to find the potential difference between B and E na. B and E. Okay. Just focus on the point B and E. You can take either this path, or either you can take this path. So I am taking B, C, F, E. Path B, C, F, E. I am taking. So when I am moving from B to C, there is nothing. Only there is B, point B. So I will write B, potential of point B, and here we have this. We are moving in the opposite direction of current, so I will write it as plus 5 I1 minus I2. Okay, and this also we have plus 2 I1 minus I2. Now we are moving in the decreasing potential direction. Is this diagram correct now? This is 5 volt now. This is 5 volt. Okay, fine. This is 5 volt and we are moving from B, C, F and E. B, C, F, E. So this you will take minus because you are moving from higher to lower potential. This you will take as minus 5 and this is minus BE because the potential you will take this minus and this equal to 0. So from here you can find the potential difference between B minus BE. All the values you already have. I1 minus I2 you have, I1 minus I2 you have. You can calculate it. Okay, can you calculate it now? All of you? This
Oh,
thing?
okay, sir.
You have this I1 minus I2, you have this also. You have to have just calculated. Okay, just note this part from here. Just note it down from here. This question has been completed now. Just note it down. We will solve one more question. Hmm. Hmm. Guys, can I take your 10 to 15 minutes extra today? Matthew,
Okay, sir. You can take 10 minutes.
Nabal, and Nafisa.
Okay, sir.
If you are having any other class, then you can tell me all of you. Nafisa,
Yes, sir.
Nawal, what about you? Are you agree with this?
Yes, sir. Okay.
Completed this?
Yes, sir. Completed.
Matthew completed,
Yes, sir.
and Nawal, you also. Okay. Just take a break of 1 minute, and we will continue. We have this question now, so you can see the question. This is based on the Kirchhoff law, and this question I have given this as 1 star, and this is very easy question. When I will solve it, then you will find it. Okay, just take the break of 2 minutes, and I will take your at least 10 minutes or 15 minutes, not more than that. Okay, so please have patience. Okay. Okay, all of you. Now we have this type of question. We have a cube, and at uh, on each side, or you can say each edge, this is edge, edge. This is edge. On each edge of cube, there is a resistance, and we have to calculate the equivalent resistance across diagonally opposite ends. Okay, just see this. We have to calculate the resistance, equivalent resistance means we have to calculate. So see this. This is looking very complicated. This circuit is looking very complicated. Actually, we have to find the equivalent resistance between this point G and between this point A. Diagonally opposite points. Okay, this is the diagonal of this square, and at each edge there is a resistance here. So Nafisa, how many resistances are there? Can you tell me?
12.
Very good, 12 resistance. So here are 12 resistances. Okay, and which combination of resistance is this? We cannot define the combinations, and this is not the series and this is not the parallel combination. So we cannot solve this type of circuit, this type of question with the help of that. So what we will do, we will do a simple thing. I am telling, just wait and see. I will take only 10 minutes. So what you will do, you will just connect a battery like this. This is the battery, okay, like this, and suppose this is the EMF of the cell or a battery. Suppose you have connected, you want to calculate the equivalent resistance between this point G and this point A, and what you have done, you have just connected a battery or cell in between this point like this with the help of this wire. Okay, just see this now. What will happen? This is the positive terminal and this is the negative terminal, and current flows from positive to negative. So suppose the current is coming from here like this. Current is coming from here like this. So when the current is coming from here like this, and this is the junction point, this A point is the junction point, and from this point, this current, suppose this current is I, this current I at this junction point will be divided. Here are three branches. One branch is this, one branch is this, and one branch is this. In all the branches, this current I will be divided. And one thing here, one thing is here. Here is the symmetry. Symmetry means you can say that here the resistance is same, here the resistance is same. Means in this branch the resistance is same, in this branch the resistance is same, in this branch the resistance is same. So you can say that the current will divide equally. Here the current will, in this branch the current will go I by 3 current will go. In this branch the current I by 3 will go. In this branch the current I by 3 will go accordingly. Okay, is it fine or not?
Yes, sir, it's fine.
Yeah. This is very beautiful question. So now we have just divided the current here. Now you can move, you are at this point A, now you can move from A to D. Okay, here is a junction point again, here is a junction point again, and what is the current here? Here is the current I by 3. Means in this AD the current is I by 3, and this I by 3 will again divide into two parts. From this point D there are two branches, one branch is this, another branch is this. So this current will be divided like this, I by 6 and I by 6. I by 6 means you half current will go in this branch and half current will go in this branch. And what is the half of I by 3? Half of I by 3 is I by 6. Okay. Okay. Now come to point A and move to here. This is the junction point, and here the current is I by 3, and this I by 3, from this point E there are two branches. This I by 3 will be divided into two branches. So here the current will be I by 6 again. Here the current also I by 6 again. Okay. Now move from A to B. Here are two branches, this branch and this branch. Here the current is I by 3. So this I by 3 will be divided into, in this direction, I by 6 and I by 6. Now just move to point H. I by 6 current coming from here. I by 6 current is coming from here, and I by 6 current coming from here. What is the current in this direction? You will add both the currents, IY6 coming from here, IY6 current coming from here. Both the currents will meet at this junction, and we will add IY6 plus IY6. We will get the current IY3 here. Okay. So now come here at this point B. IY6 coming from here, IY6 coming from here. So at this junction, the current will be IY3, means at this junction both the current will meet, and we will get a current IY3 here in this direction. And now here, from here the current is IY6 is coming, from here the current IY6 is coming. So in this wire the current will be IY3 again. Okay, here the current IY3 again. So now you can see IY3 is coming from here, IY3 is coming from here, IY3 is coming from here. When you will add, you will get the current I. So see here, the current I is coming and the current I is going out. Okay. So this is the current division is the main part here. Now you can choose any of the loop. You can choose any of the loop and you will apply the KVL. So I am just choosing a loop, this loop ADHGEA. I am choosing ADHG, and suppose this is a point K. I am choosing a path for applying the KVL not G, D, ADHG, K, and A. This is the closed loop now. ADHGKA. This is the closed loop. Okay. So now apply KVL. Apply KVL. So from A to D, this is IY3, and you are moving in the direction of current. So how we will apply? This will become minus IY3 into R. Okay. This is minus IY3 into R. Now from D to H, current is IY6, resistance is R, and you are moving in the same direction. So you will take this as minus IY6 into R. Okay, D to H, and H to G. When you will apply, you will write minus IY3 into R. Minus IY3 into R you will apply. And from G to A, when you will come, here is only one cell, and you are moving from lower to higher potential, so you will take this E as plus E, and this is equal to 0. Now you will take the LCM. 6 will be the LCM. Here you will get minus 2 IR. Here you will get minus IR. Here you will get minus 2 IR. This is plus E. This is equal to 0. So this is, here you will get minus 5 IR divided by 6 is equal to minus E. This minus E and this minus and minus cancel out. This is 5 R by 6. This is E divided by I. And this is the R equivalent. What is the R equivalent? R equivalent is equal to the total EMF divided by the total current. And this is come out to be 5R by 6. So R equivalent is equal to 5R divided by the 6. This is your answer. How I have calculated? I have calculated the R equivalent is equal to total EMF divided by the total current. So right here, R equivalent is equal to total voltage divided by total current. So in this way, you can find the resistance, equivalent resistance between G and A. Just note it down. All of you just please note it down. So this is the last question of KVL and KCL. And after completing it, you can leave the meeting and we will meet in the next class. And in the next class, maybe I will finish this chapter. Okay, got it, Matthew?
Yes, sir.
Nawal
Yes, sir.
and Nafisa. Nafisa, are you
Yes,
getting this?
sir.
Means you have to divide the current accordingly. When you will do practice, you can get it. Okay. Just copy this. So the equivalent resistance in this case, we are getting 5R divided by 6. Should I zoom in or zoom out?
Zoom out, sir.
Zoom out, sir.
You have made this. Okay. Have you made this diagram?
Yes, sir.
Okay.
Yes,
This is
sir.
the question and this. Yes. What you want to say?
Yes, sir. I made the diagram.
Yeah. This question is looking complicated, but believe me, this question is very, very simple. If you have divided the current accurately, then you will get your answer easily.
Sir, can you scroll?
Okay. Nawal, should I scroll? Matthew, should I
Yes, sir.
scroll?
Yes, sir.
Yes, sir.
You have completed this diagram?
Yes, sir.
Okay.
Yes, sir.
Because this diagram is very, very important. Okay. Just you can note it down. So this type of question you can get in your exam also, where you have to apply the Kirchhoff's laws. And this Kirchhoff's law is very important topic for your board exam. And generally, the students are confused in this topic because they do not know how to take the direction, how to choose the loop. I can only help
Does.
you to understand. I can only help you to understand. Just listen. But practice you have to do by yourself. Yourself. I can show you the path, but you have to travel on that path. I can only show you the path. Okay. But the traveling part you have to follow. Okay. All of you completed.
Yes, sir. Yes, sir.
Okay. And do you have any doubt in this? Means in this Kirchhoff's law and all that? And I also know that you are having a class of 1 hour and 30 minutes. But what we can do? We have to complete the syllabus on time. That's why we are here. Okay. So okay.